Welcome to our Final Capstone Project presentation. Our team, comprised of Paul Adams, Richard Lee, Justin Rufty, and myself, Jacob Phillips, developed FauxBank, a deliberately insecure banking web application. FauxBank is designed as a safe environment to research and patch vulnerabilities from the OWASP Top 10. The goal of the project is to simulate real-world attacks, then apply secure coding practices to fix them. This project also includes detailed reports documenting these vulnerabilities, exploitations, and remediations conducted by us. This project matters because, according to a global application security study done by Checkmarks last year, 92% of companies they surveyed experienced a breach due to vulnerabilities in applications they built in-house. FauxBank bridges the gap between theory and practice, showing exactly how these issues occur and how to prevent them. The application was developed with Flask, Python, and other common web technologies such as JavaScript, HTML, and CSS. We use Postgres for our database and have the entire application containerized using Docker. Now, let's look at some of the key use cases. First, user login and authentication. The insecure version is vulnerable to SQL injection to gain unauthorized access to the application, whereas the secure version uses parameterized queries and input validation to block these attacks. Second is the account dashboard. The insecure version leaks unencrypted account data, whereas in the secure version enforces encryption and data masking. Third is the admin portal. The insecure version enables privilege escalation via URL manipulation, whereas the secure version enforces role checks and strong session management. And lastly, security logging. The insecure version lacks monitoring, allowing attacks to go unnoticed, where the secure version implements robust logging and alerting for suspicious activity. By pairing insecure and secure versions, FauxBank lets us see exactly how attacks work and how to stop them. Now I will present my contributions to the project. At the beginning of our project, I started by creating mock-up wireframes in Figma, which helped us plan the app's look and user flow. Alongside that, I designed the entity relationship diagram in PHPMyAdmin to clarify how the database should be structured for our app. I also revamped the README to improve our project's documentation. For the front end, I completely overhauled the UI and branding to reflect these wireframes, as well as develop the dashboard and admin components that form some of the core user experience of our application. Additionally, I consolidated the web app into a Docker container, as the database was initially set up this way. This made the app very easy to deploy and run consistently across different environments, simplifying setup for users and developers. From a security standpoint, I implemented vulnerabilities, exploits, and remediation code and documentation for two major OWASP vulnerabilities, A01 broken access control and A02 cryptographic failures. For A01, the admin panel had this broken access control vulnerability as it was accessible through an insecure direct object reference. I secured it by enforcing proper authentication, ensuring only authorized admins can access it. I also addressed the cryptographic failures vulnerability by adding data masking on the dashboard, as well as applying AES-256 encryption to the account numbers stored in the database, protecting sensitive data both in transit and at rest. Though the design of the app wasn't the focus of the project, a key challenge was ensuring that the app closely reflected the mockups to provide a usable, intuitive experience. This was important because we wanted FauxBank to be a straightforward tool that anyone could use to learn from. Balancing this with the time-consuming process of researching each vulnerability, developing exploits, implementing fixes, and thoroughly documenting everything required careful planning and prioritization. Overall, this project strengthened my skills in secure coding and modern deployment practices like containerization. I will now hand it over to Paul Adams.
Hi, my name is Paul Adams, and I will be discussing my contributions to our website security research project. So my contributions to the project are highlighted on this page, but at a high level, some of my highlights are creating the initial login page design for our application, coordinating and submitting project update number 1, and then really the meat and potatoes of my work centered around the two attacks defined by OWASP, A03 and A09. A03 is the injection vulnerability, and A09 is security login and monitoring failures. So for our project, we each took some of these top 10 attack vectors from OWASP, and we did research. We performed penetration testing to see how vulnerable our application was to these attacks. And then, most importantly, we researched and implemented remediation strategies to address some of these attacks. So for my work, because, for example, I focused on A09, which is security login and monitoring failures, one of the deliverables for my end of the project was to research, test our application against this type of attack, or in this case, more of a lack of features, and then implement some remediation, which in this case was creating database logic and server-side code to help track whenever SQL injection attacks occur against the application. Finally, we each wrote research and remediation papers. So for my work, I focused on A03 and A09. A paper was written on each of these demonstrating my work, the remediation, and talking about some of the technical strategies to counteract these attacks on our application. So before I show you kind of a demo of one of the remediations, wanted to quickly talk about the tech used, some of the dev steps, and the challenges faced. So the tech stack we used was fairly simple. It was focused on Flask and PostgreSQL, and the dev steps were quite simple. We had a system on GitHub where we each worked on a feature, and then when we pushed it as a PR, it was initially requiring the review by another teammate before being merged into the main branch. Some of the challenges we faced was, kind of learning there's lots of different ways to penetration test, and there's lots of ways to remediate a lot of these attacks. And part of the research was just finding out, what can we implement based on our tech stack? Because there are remediations that maybe we can't implement due to the technology choices that we made. So as an example, one of the remediations was creating a database table that tracks injection attacks and then alerts the appropriate users of our application to this attack.
So for my section, I started by laying the foundation of designing the PostgreSQL database and seeding the realistic test data for users, accounts, transactions, and logs. I also Dockerized the database and also added a health check for Postgres. On the app side, I built the pay bills UI and back-end route. The secure path uses parameterized inserts, and I left a clearly marked insecure branch so the team could demonstrate A03 injection safely during testing. I also, to help support A09 style monitoring, I implemented centralized auditing logs for logins, payment attempts, and authorization denials. My first major security focus was OWASP A05, which is security misconfiguration. I found an IDOR on /profile/ID where any authenticated user could view another user's profile by changing the URL. So I fixed this by adding in a decorator at login required, which enforces ownership at the route boundary, and it removes any trust in the question mark ID equals query parameters. I also hardened /admin to check current user.isAdmin on the server side. And so after the fix, if you try to load a different profile, it will return a 403 forbidden error and is recorded in the audit log. Accessing one's own profile continues to work as expected. Non-admin users now receive access denied, admin only on /admin, while admins can load the panel normally. And these changes align the app with OWASP guidance by making authorization explicit and denied by default at sensitive endpoints. Then next was A06, which is vulnerable and outdated components. I audited our deployment and removed host published services that were using weak defaults. So I stopped exposing Postgres to the host. I pinned image versions for Postgres and PGA admin to prevent drift. I rotated the default credentials and constrained PG admin so it's only accessible in development without being open to the entire network. And I updated the app's database URL to use the internal hostname and the rotated secret. So retesting this confirms that Docker PS no longer shows 0.0.0.0540 540.32 and is connected to connections to local host 540.32 from the host fail as expected, and the web app connects over the internal network using the rotated secret. And PGA admin requires non-default credentials and can be bound to local-only access when enabled. So overall, the pinning versions make rebuilds deterministic and audit-friendly.
Hello, my name is Justin Refty. My contributions were setting up the GitHub infrastructure and addressing two OWASP vulnerabilities, AO4 insecure design and AO7 identification and authentication failures. On the GitHub side, I set up the entire repo with branch protections, pull request reviews, and I also set up our project board that we use to work in parallel without any conflicts. I was also author to some of our documentation, recently updated the README. I was the author for our team poster and wrote my portion of the project guide and my vulnerability guides for AO4 and AO7. AO4, basically we found that this here says ID equals 1, but if you changed that 1 to a 2, you would literally go from Richard to Jacobs. So the fix for this was to remove any sensitive IDs in the URLs and also use session-based checks in our code so that the server blocks any tampering with sessions. So now you'll notice this just says dashboard with no ID, but due to the sessions code, even if it still said ID equals 1, if you changed it to 2, you would still stay within Richard's. For AO7, I was able to show that using a sniffer like Burp Suite, that because we were using HTTP, you could see the credentials in plain text. Now, this is a cryptography. However, this does have some overflow to AO7 because it does involve somebody stealing identification and authentication. So the fix for this was to actually enforce HTTPS instead of HTTP. So what we did was set up our configuration within Nginx, which led also to helping start a server key. Now any HTTP attempts redirect to HTTPS, and because the connection is encrypted with the server key, man-in-the-middle tools can't read the credentials. I found my biggest challenge was splitting my time between the infrastructure, documentation, and vulnerability work, as well as other classes work. But I solved this by setting up the GitHub early so that I could focus on the testing and the fixes, and would generally try to get my work done ahead of time. This project, this whole class was important to me because it helped me to learn to build security in from the start, to identify, fix, and verify as you go so that you don't have to go back and fix mistakes.
As we wrap up, we plan to make FauxBank open source, allowing the wider community to collaborate on and expand the project. This way, developers and security professionals can continue improving the tool and adapt it to address new vulnerabilities. FauxBank will support ongoing education in web application security and serve as a hands-on learning resource for current and future students well beyond our graduation. Ultimately, we want FauxBank to be a lasting contribution to real-world security awareness and training.